Okay, we're gonna get started. So first off, looking at last week's attendance, it looks like people chose that an unrealistic pen. Was it like your best unrealistic pen? Oh. So for unrealistic pen, you'd want penguin was the highest, so that makes sense. Penguins are pretty cute. Okay. Actually, that wasn't that cute. Penguin was Michelle's example, so you guys need to be more creative. We're very disappointed. But basically, I like how everything else is 4.2.
That's just everyone else put only one thing.
It looks like everyone put one thing except for koala, which had two. So yeah. Okay. So let's get started. So first off, today we're going to be talking about artificial intelligence. Ignore that. The roadmap for today is looking at what is AI, what's the definitions, what's the scope of it. Moving on to bias of AI, looking at what makes AI biased, what is not biased. Then we're going to be looking at general AI, looking at something called like VAN and GAN, which is like variational autoencoders and generational autoencoders. And then we're going to look a little bit at data rights. How are your rights being protected when you guys are using AI tools? And then finally, round it off with some case studies. So for the first thing, let's look at what is AI. So what do we really mean when we say AI, right? So imagine you're teaching a toddler to recognize different concepts. Like you're telling it, hey, this is an apple, hey, this is the burger, right? That is a lot like classical programming, which is basically when you're hard coding in these programming rules. AI flips the script. Instead of like spelling out every single rule and telling it, hey, like this is an apple, hey, this is whatever, you just give the AI model a bunch of examples, and then you tell it to, hey, like figure it out. And when an algorithm sifts through like thousands of images and notices that round things with a certain color and a certain texture are an apple versus a beige thing which with a cylindrical shape is more like a burrito, then that's what's machine learning, and that's machine learning in action. So what is deep learning, right? Deep learning, you can think of it as ML's like overachiever cousin. It stacks like dozens, even hundreds of neurons in layers. So you can picture like a huge web where each node is like a tiny leaf or an edge of a leaf or pixel of redness. And it passes up through this chain of this web until it finds the output, which is something like Apple or something else. So you'll also hear buzz about Neuro AI. So basically, Neuro AI is stuff you already interact with. How many of you guys use like Netflix? Raise your hands. Okay, exactly. Netflix's recommendation algorithm is an example of Neuro AI because you're using artificial intelligence to give yourself recommendations of what to watch. And it's that kind of stuff, right? Like your autocorrect in your text, that spam filter, your Netflix recommendation system that saves you from maybe embarrassing typos, or maybe it also gives you embarrassing text. But that is what Neuro AI is. What is general AI? General AI is a unicorn because basically what it's looking at is, can you have artificial intelligence that is as general and expansive as human intelligence? And this is like a really interesting area of research of looking at, what is human intelligence? Like, in what ways do we measure human intelligence and quantify that? And can artificial intelligence replicate that? That is the question of general AI. Can we make a system as versatile as a human mind, and it's capable of shifting context like how a human would? We're not there yet, but some people argue that we could get there. So first off, we talk about AI scope. When we talk about AI scope, we're thinking about this through 4 playgrounds. The first one is perception. Perception comes in teaching machines how to see and hear, like facial recognition and voice assistance. The next one is reasoning and planning. You can think like a chess engine or supply chain optimizer, making multi-step decisions, and you can think of it as adaptation. This is something like a recommendation system. For example, if you listen to Spotify, if you've ever gotten one of those Spotify recommendations of, hey, this is the new music or single you should check out, that is based off of your data, and that is based off of adaptation, because that recommendation system adapts or changes over time. And you can see this also on Instagram, right? At some point on Instagram, I wanted to change my FYP into being something that I wouldn't find addictive. So I went through Instagram and I purposely zoomed in and liked a bunch of posts about mental health awareness. And I purposely did not interested to all the posts I found interesting. And I changed my entire algorithm to just be posts about mental health awareness, be like, you're worth it and stuff like that, which I don't really feel like doom scrolling on because it's not super addictive. So that's an example of a recommendation system, right? For years and years, I have Instagram data telling Instagram, hey, this is the stuff I'm interested in. But when I purposely manipulated my data on Instagram, that recommendation system adapted over time, and it changed the For You page, or I forget what the thing is called, but that main page that you look at that gives you content. Yeah, your feed, yeah. But that changes that over time, right? So keep these categories in mind, because as we dive more into ethics, these are kind of the fields that we're going to be thinking about. Okay, let's go on to our next slide. So we're looking at why AI isn't like the neutral black box that we think it is, right? So AI isn't this all-knowing, all-encompassing thing of knowledge. Humans' data and humans' information is what is making artificial artificial intelligence this smart. And this means that it comes with a lot of historical biases and a lot of like nuances that come with human data. So the first thing to look into is data bias, right? So I have here sampling, historical measurement. What do these things mean? Sampling bias comes from your data having a lot of data that's skewed in one direction. So one example of this is facial ID. A lot of facial ID models are trained on lighter skinned individuals. So if you are a darker skinned individual, a lot of times its recognition isn't going to be as good as it would be on someone else. One example of this is in high school, because my high school had like a facial recognition system, and it would recognize a lot of the kids with lighter skin a lot better, but with me, it would like confuse me with any other brown kid in the grade. Another example of this is historical bias. Historically, humans have been pretty biased in different ways, and this has also led to our data being biased based on these historical trends. So this is why datasets can carry a lot of old injustices. For example, if you guys, how many of you guys are familiar with redlining? Raise your hands. Yeah, so redlining is basically this thing where certain communities were kind of gatekept to like live in certain areas, and this really skewed a lot of data sets. For example, we're going to talk about this later, but in banking, if you guys are putting in a thing to ask for a loan, your zip code could be the thing that like hurts you and harms you from getting that loan. When your zip code isn't something that is maybe a good indication of whether you would be someone who is likely to pay back a loan or not. So historical bias is teaching AI to keep over-policing in the same areas that humans used to over-police in. The next thing is measurement bias. So if we pick poor proxies, like for example the zip code, we risk misrepresenting entire communities, right? Because everyone who lives in, let's say, like 98027 is not going to be the same type of person. But an AI model might say, hey, based on our history, it looks like 70% of these people couldn't pay back the loan, maybe based on those historical biases or historical regulations, and it would penalize people unfairly. Now let's look at algorithmic bias. So you can first look at objective trade-offs, which is basically when you only optimize for one thing, you could actually end up hurting a lot of other things in the process. So one example of this, right, is let's say in that same example with minority groups, you're kind of saying, okay, we shouldn't look at zip codes, right? Let's take that out of the equation. Well, the model could look at a lot of other factors and kind of use those to figure out what the zip code you live in is, right? It could use what school you went to, if that's on your credit card history, or it could use like, when you applied or something like that. And it could basically use those other factors to figure out those pieces of information that it needs to be biased. Another example of this is architectural bias. I remember someone bringing this up in the first lecture where I was asking about classification, and I asked, if you had to classify, I think the example was bicycle or tree, how can you classify a bicycle? And I forget who, but someone said that, you could look at the background, because if a bicycle is there, it would be on the road versus a tree would have like leaves. So this actually also results in something that's called architectural bias, when you look at like maybe the texture behind objects instead of the shape. So one example of this, right, is that if you have a zebra, if you always train your model on looking at pictures of zebras, let's say like a human might not realize this, but maybe all your pictures of zebras have been trained on grass. So every single picture in your model is a zebra on some type of like grass thing, right? But then let's say your zebra like runs away from the zoo and it's like running into water, right? If your model looks at that same zebra, it might be like, hey, I was training and looking at this background of this grass, and then now that the background's changed to a different color, it's blue, it's a different texture, this is no longer a zebra, it's a fish. So this is an example of, your model could work very well because you're training it in these contexts, but then when you take it out of those contexts or those architectures, it leads to what's called architectural bias. And then the last thing is hyperparameter decisions. So one of the biggest things over here to keep in mind is regularization. So in machine learning, if you guys have taken Math 318 or ML, you'll learn this, but we have this thing called L1 or L2 regularization. So basically what this does is it helps prevent overfitting. What is overfitting? We talked about this in the first lecture. If you have a graph that's like this, overfitting is when your model is plotting your line to fit exactly those points. So it's not going to generalize well on new data because it's just fitting that old data really well, right? So what happens here with hyperparameter decisions is if you add what's called like L1 or L2 norm regularization, it's basically adding a little bit of like variation into that line. So instead of like perfectly fitting each of those points, you're making like a smooth curve that would generalize well onto new data. And these techniques work well to help the model not memorize noise and just memorize those general things, which is good. And this also helps keep models more general. So that way you're not focusing on a single feature of the data set, but you're focusing on everything generally. Because this would help with something like that zebra, for example, where that model might be learning about the background and then being like, hey, based on this background, I can overfit this data and immediately be like, hey, this is a zebra, this isn't a zebra. But when you add a little bit of that noise to regularization, it allows the model to look at other features outside of something like the background. So now let's go into feedback loops. So under feedback loops, we have self-fulfilling prophecies. So if you have an area that you're saying is high maybe your state of Washington has put like a lot more cameras in that area because it's like, hey, it's a high crime area. What does that mean? That leads to more data being collected in that area, which might also lead to more crimes being collected in that area. And your AI could conclude that crime is worse in those spots when it really isn't. It's just that there's more surveillance there. Another thing is reinforcement cycles. Every single bias model would probably have, like every bias prediction generates more skewed data, and that system keeps on ratcheting up biases. So there's also this thing that's called like artificial data. So sometimes people will make their own, like synthetic data. People will make their own synthetic data when they're training new models because you don't have enough data out there. So it's this thing called synthetic data. Basically, you're just making new data to train your models. But this thing could also lead to bias because you're using your old data to create new synthetic, like fake data, and that same data could end up skewing the bias more and more, right? So now let's talk about human in the loop. So this is annotation bias. Labelers, or like human labelers, like classify data sets and bring their own backgrounds and blind spots to that. So let's say like you have like a sarcastic tweet, right? And it says like, oh great, another Monday. One human might classify that as being like a sarcastic tweet versus another human might not classify that as a sarcastic tweet. But this is an example of bias because based on the labeler or based on the annotator, it could lead to those labels being classified differently, right? And that might be something that you don't realize. And this is also something that would vary very differently based on cultures and communication styles, and it's interesting to examine in like language learning, large language models, because in different areas and cultural contexts, people speak differently, people use different types of texting. Like I text very differently than my grandma, who at some point, she was like texting with an emoji, and I think someone like passed away, and she said RIP with the crying with laughter emoji, and I read that and I was like, what's going on? It was like, you just said like crying with laughter that someone passed away in our family group chat. But she actually thought it was like a crying, like a really heavy crying thing, right? But with me, with my cultural context as being Gen Z, I look at that crying with laughing emoji and I think it's like laughing, versus like with her, it was just like hysterical crying. So this is an example where, if someone was like my grandma, she could like label this data as being something that is super sad, versus I would label this data as being super happy. Obviously, this is a very brought down example, but you can kind of imagine how this example would be applied in different contexts. And the last thing is threshold tuning. So if you choose to only act when the confidence exceeds, let's say like 80%, right? You're saying, this is the measure of accuracy. If my model reaches that 80% threshold, we're going to act. This is not a technical necessity, but it's like a value judgment, right? Because let's say someone else chose to lower that bar to 75%, right? Maybe you could catch more true positives at the cost of getting those false alarms. And if you raise it, you could also miss real issues in the name of precision. So one example of this is medical predictions, right? Because if you're predicting if someone has cancer, maybe it might be better to have a lower bar of accuracy, because even if someone has like a 30% chance of having cancer, that might be better to tell them versus saying that they don't have it, right? Because you don't want to miss those potential false negatives. But in another case, like if it's like less serious, you might want to raise that accuracy. So all of these things kind of collide into real-world impact. There's like financial, hiring, healthcare, criminal justice. I think I've talked a little bit about the criminal justice side, but we can also talk about hiring. There's one really good example where Amazon had a job screening tool where they looked at previous resumes. Did I talk about this in the first lecture? I think I did. Who remembers me talking about like Amazon's resume screening tool? Oh, yeah. Okay, I just talked about it. All of you guys' hands should have been raised, so I'm going to be offended, but anyway, I'm going to move on. But basically, when you see a headline about an AI system gone rogue, you should remember about all these like under the hood metrics that I'm kind of mentioning here, like data collection, model design, human choices. All of these things are conspiring to reflect and push human and real-world inequalities. So yeah, for a question, let's see. If you guys think of like an AI system you've interacted with, maybe like a recommender, a hiring tool, a medical diagnosis app, what type of bias, whether it's like data, algorithmic, feedback loop, or human in the loop, do you think could have been at play? And what concrete steps would you take to uncover it and mitigate it? Or what's an AI system? Actually, sorry, disregard that question. What's an AI system you've interacted with? Raise your hands. All of you guys will know at least one.
You could admit that this is a safe space.
Yeah, it's a safe space. Wow. Lots of sheepish looks. It's okay, it's okay. I think one of them is okay. Come on.
We're going to sit awkwardly.
Yes. ChatGPT.
Whoa.
Any other types of AI systems you guys have worked with?
Gemini.
And you don't have to think of it as like so big as the ChatGPT, Gemini, Copilot. Obviously that's good. But I'm also saying like you can also think of like Neuro versions of AI, right? Like I said, the Netflix recommendation system. Are there any other types of like maybe narrow versions of AI that you guys think you've like interacted with?
TikTok for you.
TikTok for your page, that's a good one. Yeah, excellent. Okay. Yeah, so she said TikTok and she said Spotify. So those types of recommendation things, right? So you can kind of think of maybe like based on those like AI systems you guys have interacted with, what's like some type of bias that you think could have been at play with your AI systems? So I think, yeah, ChatGPT, maybe it could be like your previous chat history if it like saves those memories, right? But yeah, with recommendation algorithms, what could be like a type of bias that you could have in your algorithm? You can think about like what type of data is it collecting. Yeah, data about when you were born, perfect. I'll wait for one more.
Like where you sign up for your account and where you're using this phone.
Yeah, where you sign up for your account, where you're using it from, that's perfect. So like geographic and based on like your age. So yeah, that's perfect. And you can even look at maybe like friend history, right? Maybe if like 500 friends out of your 6 friends on Spotify are all listening to a song, maybe you'll like the song, right? So these are kind of examples of bias. I think if you're looking at some other bias, like, yeah, we talked about like crime and all that. So yeah, let's move on. So yes, let's shift gears. Let's talk about how AI can go wrong. And we've talked about how AI can go wrong, right? But what does it mean for AI to get it right? So this is where responsible AI comes in. It starts with principles, which are values that should guide any AI system. So the first one we're going to look at is fairness. You don't want a loan-proof model that works well for most people, but systemically denies another group of people, right? So fairness isn't just like one thing. It's not just, hey, like, do you have equal accuracy for everyone? But it's also looking at, maybe equal opportunity to succeed or adjusting for structural inequality. And this is also very tricky because, let's say you say, okay, I'm going to adjust for structural inequality in this way. There's probably like 15 other ways you could also adjust for structural inequality, right? So thinking about holistically, how can you make this data set better, or how can you make your model more fair? Then there's transparency. This doesn't mean just like uploading your source code to GitHub, but this also means like being able to explain why these decisions were made the way that they were, right? A lot of this stuff is kind of under the hood. Users don't know why they're getting recommended certain things or why they're getting pushed certain content. So it might be good if companies could tell the users why you were denied a loan or why you were flagged for fraud. And if the answer is no idea, that's probably a red flag. The next thing is accountability. If a model gets something wrong, who is responsible? Is it like the data labelers? Is it the company? Is it the person who's developing the code? Is it their boss? In responsible AI, ownership needs to be clear throughout the cycle so you know who is responsible based on what the issue is. The last issue is privacy. It's easy to think of data as fuel, but every single data point represents a person, right? So responsible systems minimize the amount of data that they collect and also anonymize where possible and put in safeguards. So that way you can't be tracked based on who you are. There's actually a lot of interesting studies that are looking at this, looking at how even if you have a data set that's supposedly anonymous, if you have another data set that's using like similar people, or if you have like 3 data points on that person, it is actually very easy to figure out who you are, even if they say they're collecting your data anonymously, just because so many things of data are being collected everywhere. So you guys can look it up, but basically, like with any data set that you're using, if they tell you your data is being collected anonymously, chances are if someone is smart enough and if there's enough like equivalent data being collected from different sources, you can be figured out for who you are, or at least narrow it down to like maybe like 2 or 3 possibilities. So these values on the board are a start, right? But what does this look like in practice? First off, it's diverse development teams. If everyone in your AI team has the same background, they're not going to recognize if there's an issue or not. So going back to the zebra example, right? Let's say you have a whole team of people working with zebras like in zoos, right? Maybe having someone who works with fish might be good because that person would be like, hey, my fish aren't, like, they might like recognize the fact that there's different backgrounds. So if there's a zebra in the pool versus a zebra in the forest, it would be good to train that model on different things. It's also important to have bias audits and fairness metrics to help you test and measure outcomes. So looking at, like, there's this tool called IBM's Fairness 360. So that's like a good tool, and I think Google's What If tool. And those things can kind of help surface those patterns early. Explainability is also key, like I talked about, having models explain to you why your loan was rejected or why something else happened and not having it be so black box. There's tools like SHAP and LIME, SHAPLIME, and those things can break down individual practices and kind of explain to you why how much each input variable affected the outcome. So by the way, this is something that companies probably could do, but they just don't want to do because they don't want to release the reasons for it, because, I don't know, maybe it could be better. But if a model rejects your job application, for example, it might be good if they could tell you like why they rejected it, right? Because if it's due to your name or zip code, that might signal that something went wrong. How many people here have applied to a job online? Yeah, perfect. So basically, if you apply to a job online, there could have been bias for that, right? It could have been like the time that you applied or what website you used to apply with. There are some jobs that are posted on like 4 different websites, so maybe like the website that you use has like a different thing. So yeah, you can look at how bias could have come in that thing. And as well as ATS screeners. A lot of times your resume is first screened through like an AI tool and then it goes to a human. Maybe with that AI tool, like I've heard that some trick apparently people are doing is they'll do like white text on the resume, so that way like it won't actually show in your PDF, but then AI tools will see all that white text and that somehow helps it. So there's a lot of like hacks like that to get past a computer. But yeah, there are areas where biases come to play. And the truth is that doing this isn't easy. It's very easy for me to kind of sit here and say, hey, like, companies should be doing this, etc. But it's really hard, I think, sometimes to implement or in practice, just because there's no magic, like, fair or perfect animal model. The thing is, like, basically our data is biased, right? Because we're humans, we have bias inherently, so all of our data is going to be biased. But it's important to recognize this and then try to mitigate it as well as you can, so that way we ensure that we're making as little damage as possible. There's also a regulation gap. Different countries have different amounts of regulation, so this leads to, like some companies may be having, or some countries may be having like AI-specific policies. Like the EU has AI-specific policies, right? But the US is still catching up, we're pretty behind. So this could lead to some companies being able to do more things in the US versus doing it in the EU. And then finally, there's also this whole thing of ethics washing. How many of you guys have shopped at like fast fashion? Raise your hands. Fast fashion is basically like they make a bunch of new clothes and it's maybe more cheaper just to like get more sales. Okay, a few people. Yeah. But basically, like, you can see some fast fashion companies are, like, turning around within the last couple of years, and they'll kind of say, like, hey, we're donating X amount of money to, like, the sustainability thing, we're being more green. Or they'll come up with, like, a sustainable line and say that makes the whole company sustainable. That's not really sustainable, right? Because even though they are doing like this one small thing, they still have like 95% of their business, which is still unsustainable. So you still see this with companies. Like companies will roll out shiny like responsible AI policies and kind of say that, they'll publish like a blog post or something saying, this is important, like your data is important, etc. But maybe there's no follow through with that. So these are all kind of important things to think about. And in the next section, we're going to look at some ethically tricky areas like Gen AI and copyright. So this is like one of probably the thorniest areas of AI ethics is looking at IP and copyright within AI. It's where things get especially messy with Gen AI tools like ChatGPT, DALL-E, Llama, etc., or Midjourney. So basically, here's the basic setup, right? So these models were trained on massive data sets, often scraped from as much data as they can get, because generally the more data you get, the better. And what happens is a lot of that data is like public articles, public paintings, memes, etc. And all these things have perhaps like ownership rights, they're copyrighted. Like artists, writers, creators put time and emotion into their work. A lot of times they would get paid, but now that these things are being scraped, none of them got asked for permission, and this also could lead to people copying these tools without their permission. So this leads to a lot of big questions, right? Like who owns this output? If I type a prompt into ChatGPT and if I get a picture that's exactly like Van Gogh, is that my painting of Van Gogh? Like who thinks it's my painting of Van Gogh? No, exactly. That's not my painting of Van Gogh, right? But then it's like, who made that? Because Van Gogh did make that, right? But there were all these people who made the models, etc. So yeah, it's very tricky. Like, is that Van Gogh's estate? Like, if I make sales with that, should he get a portion of my payment? I don't know. And also looking at, can creators opt out of these systems? Because a lot of times artists don't know that they opted in just because their stuff got scraped. So there's some databases like Have I Been Trained that are online, which let artists see if their work was used. But in most cases, they're not going to know, right? And then another thing is training on copyrighted work fair use? Some argue that it's like a student who's learning by looking at examples. Like it's like me reading a math textbook, right? I should be allowed to read a math textbook and then regurgitate my own math and do it on different things because I got that knowledge and now I can do it. But other people say it's kind of like building a product off of some other people's unpaid labor. If you know any like design majors and stuff like that, some of them are getting stressed out because they're like, hey, someone could just use ChatGPT and just make a bunch of designs. So it's kind of like looking at that. And this isn't just like a thought experiment that I'm just like posing these questions at you guys and you guys should sit with hypothetically. There are lawsuits happening right now with this. So one example of this is Getty Images. Have you guys heard of Getty Images? Yeah, raise your hands. Yeah. So getting images is basically just like this website. It has a bunch of images and it has like that copyright stamp on it, right? Right now they're suing this company called Stability and Stability AI for scraping millions of images off of these watermarked stock photos. And that lawsuit is still going on right now. There's also another lawsuit by the New York Times, which I'll talk about in the next slide. They're suing OpenAI, claiming that a lot of the article's content was scraped. And New York Times, as you guys know, is behind the paywall a lot of the time if you go past your article limit, or I don't know. But the issue is that now users can maybe ask the New York Times to like summarize something without paying for the paywall, and then that kind of goes against their whole model, right? Because they rely on number one data or like ads, and the number two thing is their rating. And there's also smaller artists who have seen like AI tools replicate stuff very similar to their work without giving them any credit. So that's also another issue. So what do we do? Does anyone have any ideas for like what we could do? It doesn't have to be right. Just be like. I'll wait for one. I'll give you guys like a few proposals then, and I'll have you guys rank them. So basically, like the first proposal is researchers looking at watermarking AI output. So if you output like a thing of a painting, maybe you could say like, hey, this was, if you click on it for more info, this was like 63% based on like Ariane's Van Gogh painting, and 20% based on Mish's painting. It could be something like that, giving credits. Other people are building opt-out databases so that way artists can opt out of their work. And there's also a growing talk of licensing. So if we treat training data like music samples, if a data set uses your work, can you get something out of it? So yeah, out of these three policies, who thinks that watermarking AI outputs is the best? Okay, one. Some votes?
Everyone has to vote once.
You have to vote once.
I am watching Blue.
Yeah. Who thinks that building like opt-out databases are good? So you can opt out of your data being used in the model. Raise your hand. And then who thinks that licensing is a good idea? So if your data set uses your work, you get something out of it.
They're cut.
Awesome. Yeah, so it looks like most people kind of like the second option, but people like the first and the third option as well. So yeah, it's like still early days also, just because I think a lot of people in these legal systems were built to like learn how to handle situations where like machines can just use millions of people's data points and then output something. So it's not only just about law, but it's also like what type of AI culture do we want to create, right? Do we want to create an environment where creators are respected, or do we want to create an environment where anything online is fair game? If you posted it, it's fair to be scraped. So now let's move on to a topic, or let's actually move on to this example. So here's the New York Times example I talked about. It's an article. They actually sued OpenAI in 2023, but the lawsuit's still going on. And yeah, they basically argued that it wasn't fair use for OpenAI and Microsoft to scrape their content because it's unfair on journalism, like ethics. Just because ChatGPT can do things like summarize New York Times articles, like direct people to those articles as well, and quote them without even giving like the original source. So users could get those core ideas without even paying behind that paywall. And even though it isn't currently illegal under the current law, it also like raises ethical questions about like public journalism. What happens to public interest journalism when AI can just absorb it and recreate it without payment. And yeah, and it's also because journalism is very labor intensive and expensive. So if people are working in these fields where they can just have AI come off their work and profit from it, it's not so good. So now let's talk about what happens when AI just doesn't analyze the world, but it also starts generating it. So first off, looking at VAE, a variational autoencoder. This is like a type of model under generative AI. And essentially what this does is it takes input data, which are kind of like face. Oh yeah.
So this is kind of late, but how does what's like the legal status around like scraping data from like cognitive images and like using
Yeah, so in terms of like legal status, the lawsuit's still going on, so I think they haven't actually like resolved it at all. I think last I checked, like January 2025, there was like a new article coming out about it. So I don't think there's a status right now saying like explicitly like, hey, if you do this, it's unfair. Hey, if you do this, it is fair. It's still kind of ongoing, and I think that's also just because like America's law system takes so long to come to these types of what's it called? Legislative things. regulations. So even if AI is moving at like, let's say like an expert pace, our law system is like only moving at X, right? So if like the rate of change of AI is this fast, it's kind of hard for a regulation to catch up. So that's why what we're seeing is that, we're getting a lot of these new improvements coming out really quickly, like even deepfakes, which we're going to talk about later. But it's probably going to take maybe like 5-10 years for for our legal system to catch up. So yeah, that's like, it's not a good answer, but yeah.
Also, as a whole, is the lawsuit like on Copilot with OpenAI or is it like Microsoft shared on OpenAI?
It's OpenAI and Microsoft.
Like
Copilot.
Copilot.
Yeah. I think so. But yeah, I'll double check on that. But yeah, I know it's Microsoft and OpenAI. So yeah, looking at generative AI tools. So one of them is a variational autoencoder. So basically what it looks like is it takes input data, like faces, and it compresses it. And then later it takes that same data and then it decodes it. And what this basically does is it helps make like new faces, for example, which could be like statistically plausible, right? So let's say I took all of your guys' faces right now, right? I decompress that data into a tiny little face, and then I'm basically just like putting it into this thing, and then I'm decoding that. And then I get a new face, right? So basically that means that I could maybe make like a new picture of a person who doesn't even exist, face, which looks plausible. Like if the other person looks at it, then you would think it's a real face, but it really isn't. I'll actually, let me pull up a website. There's this website which is like a person generator. AI person generator website. Oh yeah, it's called This Person Does Not Exist.com. It's a very, very interesting title. So basically, I'm just going to pull this up. This is a website called thispersondoesnotexist.com. Basically, what happens is every time you refresh the web page, it generates a new picture of a random person, and this person does not exist. But it looks very real, right? Like if you saw a picture of this person on Facebook, you would be like, hey, that's like a real person. But she doesn't exist. It's just based off of people's faces being decoded and then, or encoded, and then passed into this thing, and then decoded. So let me refresh this page, and I'll just pull up a few more faces. This is another person. She does not exist. Another person does not exist. Another person who doesn't exist. So as you can see, this webpage is basically just pulling up pictures of people, but they aren't actually people. It's just they're making up new faces. So this is like generative, right? Because it's kind of putting up those outputs. The only thing though is this is actually probably a better idea of GAN, but yeah. So variational autoencoders, like the one issue about them though is that they're kind of like fuzzy. The outputs tend to be very smooth and soft-edged and kind of like dreamlike. So that's why they aren't as realistic because they prioritize like the structure and representation over having like picture perfect like realism. Versus like our next thing we're going to talk about, which is generational autoencoders. Those work like a digital con artist. So basically, it's kind of like the generator is producing this fake content while the discriminator catches the fake. So I have this little model up here. It's a pretty good representation of GAN. But what this is doing is it's generating fake content, and then it puts it through a discriminator, which sees, hey, how much of this content is fake. And then over time, the generator gets so good at generating new content that the discriminator can't even tell if it's fake or not. And this is when you get those like hyper-realistic faces like thispersondoesnotexist.com, or get videos, which I'm going to show in the future, and like full motion videos, right? So it sounds powerful, right? You could generate pictures, I guess that could be cool, but it's also super dangerous. And this leads to things like deepfakes, where there are now AI-generated videos and clips of people doing random things that they didn't actually do in real life. And we've seen deepfakes of politicians confessing to fake scandals. We've seen fake videos used in war propaganda, and most commonly, but disturbingly, they've also been used in like explicit content, often targeting women. So the ethical violations here are huge. People's likenesses is being used without their knowledge, without their permission, and without their control. And because this content looks real, victims online are unable to realize if this is fake content or if this is real content before the damage is done. And this is the crisis of authenticity. In a world of deepfakes, how can you trust the video evidence that you see online? How do you trust your own eyes? And there's also a lot of serious gray areas, like who owns the output of a deepfake? If I generate a fake image of a person, is that my image of that person, or is it all the people's images that were in my database's image of the person, if that makes sense? And especially again, generational autoencoder networks, those were trained on millions of faces from the internet. So if we're doing that system with a few people, which a few people said earlier, where every single person gets a little bit of a contribution if their thing is used, if my data set is trained on all the people in this classroom, every single time I generate an image, should I give all of you guys a 20 cents? You know? So that's kind of like a new potential part of the raw material that fuels these systems. So it's fully uncharted territory. You know, technically we're advancing very fastly, but ethically and legally we're struggling to keep up. So let's go into an example of deepfake. Let's see if this video loads. Here's my mouse. Okay. So here's an example of a deepfake I'm going to play for you guys real quick. So basically, Facebook refused to remove a doctored video of Nancy Pelosi. And what was she saying? I forget what she was saying. But they refused to remove like a doctored video of Nancy Pelosi. So this artist, whose name is Bill Poster, he posted this deepfake on Facebook, basically having Mark Zuckerberg boasting about how the platform owns its users in retaliation. So I'll play it real quick.
I wish I could keep telling you that our mission in life is connecting people, but it isn't. We just want to predict your future behaviors. Spectre showed me how to manipulate you into sharing intimate data about yourself and all those you love for free. The more you express yourself, the more we own you.
Who here uses Facebook?
Not me.
Yeah, I got it on it recently for Facebook groups, but besides that, I don't use it. But yeah, basically, like, you know, a lot of people use Facebook, a lot of people can get that content, especially older people who aren't as familiar with deepfakes as you might be. And rate on a scale of 1 to 5, like 1 being believable, 5 being fake, how believable do you think his like speaking video was? Raise your hand. Say 2s. And then, wait, did I say 5 being believable?
Yeah.
Okay.
No.
Okay, 5 is believable, 1 is not believable. 2, 3. Yeah. Okay, that's pretty good. 2s and 3s. Are you guys saying that based off of like the video of like his like facial movements while he was speaking, or are you guys saying that based on his content? I can replay a little bit if you want to.
I wish I could keep telling you that our mission in life is connecting people, but it isn't. We just want to predict your future behaviors. Spectre showed me how to manipulate you into...
So do you guys think that right now the reason why he looks fake is because of the way he's talking, or because of the content he's saying?
The way you saw.
The way he's talking? Yeah. I see that. I think his eye movements are slightly like unnatural. But, you know, this is getting better and better over time. There's also this video of Tom Cruise, which I didn't put on here. But yeah, basically there's this video, or a picture of Tom Cruise, and this guy on TikTok duetted that video, and he basically put Tom Cruise's face on his own face, and it was super realistic. It tricked a bunch of people. So basically this AI and deepfake technology is getting better and better. So yeah, it's kind of looking at also how, you know, Facebook would remove this AI-generated video, but then it was kind of used against them. So it's kind of looking at, you know, would Facebook react differently if its own founder is being involved in that or manipulated or not? Yes, let me move on. Give my mouse back.
I wish I could keep telling you that our mission in life is connecting people, but it isn't. We just want to predict your... I wish I...
So now it's the next thing. We're going to look at self-supervised learning, or SSL, in AI. So this is one of the most transformative shifts in AI that we have today. And the basic idea is surprisingly human, right? So it's kind of saying, like, you know, if you have a baby, going back to that example, learning about the world, right? And it's learning, like, you know, what's a cat, and it's learning that through a flashcard, or what's an apple, and it's learning that through a flashcard. Or it's not learning that through flashcards, because babies don't learn through you giving them flashcards, they learn through observing the world. So, and baby would probably, you know, try to eat a cat or something and then feel fur and not eat the cat. But then would go and eat the apple and then it would taste it and be like yummy and then it would eat it, right? That's kind of how babies usually figure out if things are cats or apples. But anyway, so in SSL, models learn from this like raw unlabeled data, similar to how humans learn. So instead of me kind of telling the model like, hey, look at this image, this is the image of a cat, hey, this is an apple, this is the image of an apple, we're kind of setting up a puzzle for this model. So for example, in text, the model might hide a few words and say like, hey, can you guess the missing word? So if I had a sentence being like, you know, this classroom is very big, maybe I would hide the words very and I would hide this, and I would just say classroom is big. And then I would have like these two gaps of trying to predict what are those two words. And the model is basically trying to guess what those missing words are. So this is what models like BERT and Roberta do. If you guys have heard of BERT, it's basically like a natural language processing technique. But basically, and we're going to talk about that next week, so stay tuned. But in this process, they learn the structure of language. So they learn maybe the grammar, the meaning, the context, all without explicit supervision. So now let's talk about vision. One of the biggest breakthroughs came from Meta AI with a model called SEER, which stands for self-supervised. SEER was trained on over 1 billion unlabeled Instagram images, and it's wild because there was no categories, there was no human labeling it, saying like it's a dog or a cat. It was just like a bunch of images thrown at this model, and just using the images itself, it was able to match or outperform many supervised models on tasks like object classification. This is crazy, right? Because all of these other models were being explicitly labeled by humans and saying like, hey, this is a cat, hey, this is an apple. And this is another example where there was no labels, no nothing. It was just tossed a bunch of these images and it's told like, hey, based on these images, filter them to different categories and classify them as different objects, even though you don't know like, what the names are, etc. And it was able to just do that. So why does this matter so much? First off, labeling data is super expensive, it costs a lot, and it's also a lot of like manual labor, etc. And sometimes it's very slow and impossible. For example, for things like low resource languages that aren't used as often, or for rare diseases or abstract ideas, labeling everything in your data set is often impossible. But what self-supervised models do is they unlock all that unlabeled data that you can't go through and label on your own, and they help you build more flexible, generalist AI systems that can learn across domains. And second, and this is where ethics come in, SSL reduces our dependence on having humans label things versus having AI models label things, because the models are the ones that are classifying it, right? It's not me telling it, hey, this is a cat, hey, this is an apple. It's the model taking all those images and saying, hey, these images all look similar, this is an object. These images all look similar, this is an object, right? So this is good because in that example earlier where I was telling you, that emoji, if it's like crying with laughter versus just crying, if I have like a model that's just kind of looking at that model would just classify it as, hey, this is like one thing, you know what I mean? It's just this emoji. Versus like a human might classify that and say, hey, this is a very sad emoji, or this is a very happy emoji. So while SSL might sound like a technical detail, it's actually like the scaffolding for a lot of powerful like models that are going to come up in the future, and it's kind of shaping the future of AI right now. So now let's come up to something that is invisible, but it's absolutely everywhere, which is called surveillance capitalism. So what is surveillance capitalism? It was coined by this Harvard professor called like Shoshana or Shovana Zuboff. But basically what this term does is it describes a business model where companies make money not just by showing you ads, but by turning your behavior into a product, and then AI supercharges that entire process. So how does it work? First off, there's feature extraction. So every like click, scroll, pause, zoom in feature that you do, it's all data. So AI systems pull that data from like a raw digital exhaust, right? Every single motion you do online is being tracked. And they don't know that you just watched that video. They know how long you hovered. They know if your mouse moved during that video. They know if you were switching tabs during that video. Like they know all of that, right? Maybe even if your eyes lingered somewhere, what you did afterwards. So that's like feature extraction. And a good example of this is my Instagram, right? I didn't only just like the videos and save them. I also would zoom into the like parts of the image that were like not super interesting, or I'd go into the comments and I'd scroll up the comments and scroll down, just to have Instagram have all those stats being tracked of things that I do with those posts. So if you guys want to change your Instagram FYP, that's what you do. But basically, that's like feature extraction, right? The next thing is segmentation. Based on those signals, the system clusters you maybe as like an anxious college student, a night owl, or a high-income tech worker and so on. And these aren't just demographics; these are psychographics, micro segments built from an AI-driven inference. So let's say you always like wake up in the morning and you watch these YouTube videos from like 6 to like 8 a.m. versus you're someone else who like watching these YouTube videos from 1 a.m. to 3 a.m., right? It might classify you into, someone who watches YouTube videos at like in the morning, and then that's kind of like the psychographic thing they're applying to you to target these ads to you. So one ad might be that, if you're watching a lot of videos at 3 a.m., maybe they send you something like melatonin. And then there comes targeting, so that's kind of what I was talking about. But this comes from the observation to manipulation, right? Because the system now shows you ads, news, even like content that's likely to keep you engaged or likely to have you buy it. And how many times have you guys like Googled something and like seen an ad for it? Or like said something and then seen an ad for it? Raise your hands. Okay, I'm impressed. Yeah, we're actually almost everyone, except for like 3. But yeah, that's happened to me all the time. I have like said something to someone and seen an ad about it right after, or I've Googled something and then all of a sudden like my Instagram is showing me 10,000 ads for it, right? So basically what this is showing you is that you are being tracked. Actively, like if you guys think the internet is free, it's not. You guys are like commodities that are being sold on the internet, right? Because like your data is being sold to these companies, so these companies can target you as a commodity for their products. So the scary part is that, a lot of people don't know this is happening, because a lot of times people say like, the internet's so great, it's free. It's not free, you're just the product. And not to be like super negative, but yeah. It's true, yeah. And it's because you don't see the features that are being extracted about you. You don't see the segments that you've been sorted to. You just see a screen that feels tailored and these ads that feel tailored to you. But you don't know what it's designed to make you do, right? Maybe these ads are gonna like systemically, move you in one direction or move you in another direction. Because let's say you've been typecast into being like a night owl, right? Maybe it was just like 1 week or something in midterms, you were like, watching YouTube videos from 1 to 3 a.m. Now that this thing has typecast you into a night owl, maybe it'll start like systemically sending you melatonin pills or something. And then this is gonna get you into a cycle where, you can no longer sleep, even though that was just like 1 week. And this is kind of a silly example, but you also see this in more serious cases, like there's Cambridge Analytica, which weaponized Facebook's data to influence voter behavior. TikTok's algorithm feeds emotionally vulnerable users, or users who they think are more emotionally vulnerable, into content that maybe worsens their mental health because that improves engagement, right? Because TikTok is being optimized to have you guys have like the longest watch time possible. How many people use TikTok? Raise your hands. Okay, how? Yeah. And then how many of you guys use like Instagram Reels or YouTube Reels? Pretty much everyone else. So basically, all of these algorithms, right? Their goal is to keep you guys on those apps as long as possible, so they can show you as many like ads or as much watch time, or have the creators have as much money as possible, etc. And then that could lead to it having malicious objectives or malicious motives, right? Because let's say you're going through a really hard time, you're crying, right? It might show you a bunch of sad videos because it knows that like the more you keep crying, the more you keep scrolling on TikTok, which is not good. But maybe and it's like also typecasting you to that area, right? So yeah, and then this is also something that happens with Amazon, where Amazon shifts its like pricing, its layout, and its recommendations based on your behavior. So it's kind of shaping like what you want for you instead of you maybe just like going on Amazon and looking what you're like searching for. So yeah, this surveillance capitalism isn't just about ads; it's about AI using your behavior and shaping your behavior at scale. And the more predictive power this model has, like the more this model is able to predict what you're going to do based on the content it gives you, the more control it has over undermining your consent, undermining your autonomy, and also undermining democracy as a whole. So the big question is, how can we build systems that understand us, right? Because at the end of the day, recommendations are kind of nice. Like if I'm on Spotify, if it gives me a new single I like, that is a nice recommendation to have, right? It's putting me onto new music. But at the same time, most of you guys probably do not want to be tracked and do not want to be pigeonholed into being like, hey, I'm a person who is up from 1 to 3 in the morning or something, or whatever it is. So, how can we build these systems that, both understand us and maybe like help us in that way, we like them that way, without controlling us? So, yeah, I don't know the answer to that, but. Also, I think I talked about this earlier, what's an AI system to interact with? So, yeah, maybe we can talk about, we can maybe move on. So let's talk about something that underpins all AI systems. So who owns your data? Who decides what happens to it? Can you even say no? So in the European Union, the answer is yes. There's this law that is called, what is it called? GDPR. So GDPR gives individuals like real rights to their own data. Basically in the EU, you can access your own data, you can see what a company has collected about you, you can also even correct it, right? If that data is collected about you, and let's say it says I'm like a 6'3" person, I can maybe correct that and say like, hey, I'm not 6'3", I'm 5'3". And you can fix errors and inaccuracies. And you can even request that your data is deleted. And this is the right to be forgotten, if you guys have heard of it. And it's one of the most influential digital rights laws in the world. It's not even Europe, it's also countries like Brazil and India that are adopting and passing their own versions. But in the United States, we have a major gap compared to other countries. There's no federal law in the US currently that gives people full control over their own data, which is kind of crazy. Instead, we have a lot of patchwork state law kind of regulations, so different states have passed different statewide regulations. Like California has this regulation called CCPA, which, how many of you guys have heard of it, CCPA? No one, right? It's not even well known. But basically, and even that only goes so far. And that is also the most well-known law. So that gives you guys an idea of how much people don't know about AI regulation. And there have been federal proposals introduced, like there's an American Data Rights Act, or Data Privacy and Protection Act, and Congress hasn't passed anything about that yet, so yeah. And there's also another way to protect privacy, it's technical design. One method is differential privacy, so this technique adds a little bit of noise, so instead of pigeonholing you into one category, it adds a little bit of noise or mathematical randomness to your data. So, let's say you have 1 week that's XYZ, it's not going to say forever you're an XYZ student or XYZ person, it's going to add some noise, so that way you can fit multiple categories, so you're not getting pigeonholed. And another one is federated learning. So basically your data is going to stay local. So if you use something on your computer, that is going to stay local to your computer, local to yourself as a user, and it's not going to be transferred onto your phone. And these approaches show that privacy doesn't mean always shutting down innovation. So protecting a user's privacy doesn't always mean that, hey, like we can't even give you these recommendations that maybe you actually find useful, but it just means protecting your data and allowing you to get the benefits from these platforms at the same time. Because at the end of the day, data privacy isn't just about compliance, it's about every one of you guys having your own dignity and consent, and understanding when your data is being used and when it's not being used, and having the power to actually delete it or use it. So if we want AI that's ethical, we need to start with giving people control over their own digital lives. So now that we've covered like kind of the technical foundations and ethical frameworks of AI, where's it? Okay. Technical foundations and ethical frameworks of AI, I will also give you guys two powerful and troubling examples. So first is Facebook, Cambridge Analytica. Keep in mind, it's around 87 million people were scraped from Facebook's profiles, and most of them without even realizing. And they didn't just grab like their name and email, right? It wasn't just like Aria, edu. They also ran psychographic clustering algorithms like I talked about earlier. So they segmented users into their personality types into these buckets using the OCEAN model, which stands for openness, conscientiousness, extroversion, agreeableness, and eroticism. And these traits were then used to micro-target political ads to people based on the bucket that they were placed into. So these were also designed to sway people, right? Because maybe if you get someone angry and you tell them, hey, your rights are being taken away, that's going to be something that they're going to click into and spend more time on Facebook ads, and thus give Facebook more money. So the lesson here is just that if you combine behavioral data with unsupervised clustering and a lack of regulation, you don't just predict people's preferences, you can reshape people's preferences into being like skewed into one place or another. Which is why it's very scary if like the government or someone else gets control over these systems, because they can really reshape the way that you think and like the information that you're being fed, because they have control over like your social activity online. The second case takes us to healthcare, where AI is increasingly used to assist with diagnoses, and you can see this issue, right? Because let's say a lot of the data has been based on like certain skin type or a certain type of person in other ways. That model might miss symptoms in you. I saw this one case of this one doctor who he was like more dark skinned, and he made a book about how like different types of skin conditions look on dark skin, because in medical school all the skin conditions were shown on white people. So obviously, you know, if your skin is like lighter, you might show something like pink, versus like if your skin tone is darker, you might not have any pink that's shown, right? It might be purple or a different color. But basically he made like a whole book, because that hadn't even been in existence in the medical realm. So that way they could be accurate, and not only just accurate, but equitably accurate, right? So not just accurate for one group, but accurate for all groups. Because you know, you could have a model also that's trained on 99% of people who look a certain way, and then you can get 99% accuracy, and that's disregarding that 1% of people who don't fit into that certain group. So have you guys ever experienced an AI system that felt like unsafe or unfair or personally victimized, like my facial recognition example?
I was also personally victimized by the same technology.
Yeah. Or I can also ask, like, how many of you guys have applied to a job and never gotten a response? Yeah, I've also felt personally victimized by that. And then that would be, you know, an AI system, right? Because it's screening you out, and it's not even giving you the reason, it's not giving you the data analytics for why you were screened out, or like the metrics that it used for it. And maybe it's something super like simple, right? Maybe you have like bars in your resume or something that are making it unreadable by like these resume tracking machines, and that's something that you would never know unless like you got that data. So, you know, maybe that's like an example that's more relevant, but there's also like other things you can think of, like guardrails, audits, or human in the loop behavior that I talked about earlier that could make these models more safe. So, yeah, I'm just gonna skip this and go to our Kahoot. Let me